Hello everyone, I am Minakshi working as an assistant professor IT department KIET group of institution. In this lecture, I will be discussing about memory segmentation in 8086 microprocessor. So let's get started. So what is memory segmentation? Segment is a logical unit. In memory segmentation, we segment memory into logical units. And here the segments can be 64 KB long. Each segment is made up of contiguous memory locations. So we segment memory into segments containing contiguous memory locations. And each segment is independent, can be separately addressed. Here, each segment will have an address. An address will be divided into two parts. One is segment starting address, or we can say base address, and an offset. Each segment is assigned a base address, the starting address of the segment, and an offset. So in memory segmentation, we will segment the memory into segments where each segment will have an address. So each segment will have a logical address. An logical address will be defined with a base value or an offset. Here, a base address is the starting address of the segment, and offset is the distance in bytes of any target location from the starting of the segment. So offset will be used to address any byte within the segment, and it will define the distance of that byte in the segment from the starting of the segment. So base value and the offset will be used to address the byte in segment. A segment base and offset are unsigned 16-bit quantities. So the size of base address and the size of offset will be 16-bit. And always the lowest address byte in a segment offset will be 0. And size of offset will define the maximum size of segment. So it will limit the maximum size of segment. Here offset size is 16-bit. So maximum size of a segment can be 2 to the power 16. The size of offset can define 64 KB size segment. A segment can never be longer than 64 KB. The maximum size of segment can be 64 KB. In 8086 microprocessor, we have maximum 1 MB memory. 8086 microprocessor supports maximum 1 MB memory. And we have maximum size of a segment 64 KB. So we will have 16 segments of 1 MB memory in 8086 microprocessor. Out of these segments, only 4 segments will be active at a time. We will have 4 segments, and out of 16 segments, only 4 segments related to a program can be active at a time. Code segment, data segment, stack segment, and extra segment. If 64 KB is the maximum size of a segment, so code segment will have 64 KB, stack segment will have 64 KB, and for the data segment and extra segment, as extra segment is also used for storing data. So data storage will have 128 KB, 16-bit content of segment register actually points to the starting location of a particular segment. As we have studied in register organization of 8086 microprocessor, we have code segment register, data segment register, stack segment register, and extra segment register. And these register stores the base address of these segments respectively. So we have code segment register to store the base address of code segment and so on. So here 16-bit content of segment register points to the starting location of the particular segment. The segment register will have minimum value 0 address or maximum address F000 because starting address of any segment is stored in segment register. So segment register can have the minimum value 0 and the maximum value F000. And the offset address, because offset address is in within the segment. So it will have minimum value 0 and the maximum value F, 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 F. So it will be the maximum size and 0 is the minimum size of segment offset. All segments begin on the 60-byte memory boundaries. This is the only one restriction of segment. With this restriction, we can have type of segments. And these type of segments can be adjacent, disjoint, partially overlapped, or fully overlapped. So we can have overlapped segments, non-overlapped segments, disjoint segments, and adjacent segments. So overlapping segment. If a segment starts before the end of the previous segment, then both the segments will be termed as overlapped segments. Here in this figure, if we see that the segment B and segment C are overlapped because segment C has been started before ending of segment B. And segment C and segment D are also overlapped. So here overlapped segments can be of two types. One is partially, as segment B and C are partially overlapped, whereas C and D are fully overlapped segments. Another type, non-overlapping segments. If both the segment does not overlap, it means the segment start after 64 KB of a segment, then the segment will be non-overlapping segment. So here in this example, we see that A and B are non-overlapping, C and segment E are non-overlapping, segment D and E are non-overlapping. Here, continuous segment. Continuous segments, a segment starts just after the location where previous segment ends. Here, segment B started as soon as segment A ends. So, segment A and segment B will be continuous segments. Disjoint segments, the segments neither overlapping nor continuous. Those segments will be disjoint segments. So in this example, segment C and segment E are disjoint. Segment D and segment E are disjoint. Segment A and segment E are disjoint. Now, in this lecture, we will see how a physical address will be calculated to address any byte in the memory. So, physical address will be calculated with the help of base address of the segment as well as offset of the segment. So 8086 microprocessor has 20-bit address. The physical address, or we can say address of memory location, is 20-bit address. We have segment starting address 16-bit and offset 16-bit long. So now we will see how this logical address will be converted into the physical address to address any byte in the memory or to address any location in the memory. Physical address can address from 0 to F, 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 F. 20 bits will have 5 hexadecimal digits to represent any physical address. So, logical address, we will have a segment base address and we have 16-bit offset. Now we will convert this logical address into 20-bit physical address. To do this, first we will shift a segment base address to left by 4 bits. 1, 2, 3, 4. And then we will add a 0. We will do a shift operation here. Now, offset will be added to this shifted result. So we will add offset to this address. Now we will have a 20-bit physical address. And this address is calculated with the help of segment base address and the offset, where the segment base address will be shifted 4 bits and the 0 will be padded at right. And now we will add offset to this shifted result. Then we will have a physical address. In this way, we can convert any logical address into the physical address. So, program deals with the logical address. And with this segmentation, we can allow the code to be developed without prior knowledge of where the code will be located in the memory. And the logical addresses will be converted into the physical address with this method. So whenever bus interface unit of 8086 microprocessor accesses the memory, it generates a physical address which is 20-bit address. From the logical address, logical address will have a segment starting address or base address and offset. And this is done by shifting left the segment base value 4 bit positions and adding the offset to the shifted result. And in this way, we'll have the physical address in 20 bits. Logical address sources. So we have 4 kind of segments: code segment, data segment, extra segment, and stack segment. And we have segment register to store the starting address of the segment for a particular segment. How logical address defined by different sources. So bus interface unit obtains the logical address of a memory location from the different sources. And these sources are defined in this table. So whenever instruction fetch operation is performed, instruction fetching operation will refer to the code segment and default segment register is code segment register, and there is no other alternative for storing the base address. And the offset will be in instruction pointer register. So it is suggested that first you should refer the register organization lecture of 8086 microprocessor before studying this topic. And for stack operation, the stack segment will be referred, and the stack segment register stores the starting address of the stack segment. So default segment base register is stack segment register, and no other register will be used to store the starting address of stack segment. The offset will be stored in stack pointer. So whenever variable accessing is done, variables are stored in data segment. So data segment register will be used for referring data segment. And the offset can be used effective address. The alternative segment registers can be CS, ES, and SS. For string manipulation, whenever we do a string manipulation operation, the source address will be in data segment, and the offset will be stored in source index register. And when the target destination, or we say that string destination, will be referred, it will be referred in extra segment, because data is stored in data segment, and the destination string will be in extra segment. And the source index register will be used to store the offset of the string, source string, and destination index register will be used to store the offset of destination string. Whenever the base addressing is used, and base pointer used as a base register, so the segment register will be used as stack segment register, and the offset will be referred as effective address. In this way, the segment starting address and the offset address will be referred to identify any memory location. And different segment register can be used for storing starting address of the segment in different operations. Different register can be used to store the offset in different operations. In this lecture, we discussed about memory segmentation and types of segments. Then we discussed about how to calculate the physical address. And then we discussed about various logical address sources. These are the references for this lecture. Thank you very much. Happy learning.